Class example 2.2.5. The painting shown is Deep Magenta Square by Richard Anushkevich. The length of the red square in the painting is unknown. The width of the border around the square is 30 centimeters. So let's write some of that information in. I know the length of the square in the painting is unknown. Let's call that X. You could call it L, you can call it question mark, you can call it whatever, but I'm going to go with X. We also know the width of the border around the square is 30 centimeters. So I know the distance from here to here happens to be 30 centimeters. Now this is true from this distance to this distance, as well as this distance to this distance, and of course top to bottom right here. Okay, now because this is a square, I know this side length is equaling to this side length, this side length, and this side length. Okay, I also know that the entire painting is going to equal to the red square in the middle, or the magenta square in the middle, plus these lovely purple bits on the outside. But I also know that that is the same thing as saying this distance of the red X plus 30 as actually a side length. So question A says, write a polynomial expression representing the total area of the painting. So I know that an area of a squared is equaling to the side multiplied by another side. That's how I get the area. Sometimes we could rewrite that as the side squared. Okay. I also know that the total area of the painting is going to equal to this side length, which is 30, plus X plus 30, or in other words, X plus 60. And the area itself is multiplying those two side lengths by themselves. So we could say that a polynomial expression, if I chose to expand this out, was going to be x squared plus 60x plus 60x plus 3,600. We can rewrite that one more time as x squared plus 120x plus 3,600. So this as an expression representing the total area of the painting. Okay. Question B says, what is the total area of the painting if the red square has an area of 3,600 centimeters squared? So let's just take a look at that for a second. We know that the red square, the area of that red square, I'm going to just call it a red and a square, is going to equal to 3,600. We also know that the area of a red square in this particular case is going to equal to x times x, which is x squared, which actually means we must know that the side length x is going to equal to the square root of 3,600. Now don't forget, we know that the area itself is 3,600. We also know that the formula for the area of the inside red square is x squared, okay? We also know that if I want to get x by itself and just know what one side length is, I have to perform the inverse operation of squared, which is square root. If I'm going to balance that out, whatever I do to one side, I must also do to the other. The squared and the square roots cancel each other out, and that's where I'm getting the square root of 3,600 from. Now, if I try and take the square root of 3,600, I'm going to get 60. So I can see that the actual side length of the red part of this painting is 60, which must mean that the actual side length of the entire painting is going to equal to 60 plus 30 plus 30, which is equal to 120. So the area of our large square, which would be our side squared, is now going to equal to 120 squared. Now I'll remind you, I'm just adding 60 plus 30 plus 30. And so if I square 120, I'm going to go ahead and get 14,400 centimeters squared as the total area of the painting.